Are you prepared to take an interstellar journey that will leave your jaw dropped and eyes wide open? Fasten your seatbelt for this cosmic story about a NASA mission that has gone above and beyond its original expectations, 45 years after it was initially launched. Even more astonishing, the spacecraft is not only billions of miles away from Earth, but also surpassing all odds as data continues to be sent back using technology dating further than cassette players. Be amazed by these adventures happening in outer space today. After decades of exploration, NASA has made a groundbreaking new discovery that's got the entire world on edge. There is something mysterious lurking in the darkness beyond our planet. What could it be? Now we have an unprecedented opportunity to uncover its secrets and unlock never-before-seen insights into our universe. It's time to boldly go where no one has gone before and discover this spine-tingling mystery from space. Hello, and welcome back to Door to the Universe. In 1965, a true rock star of engineering took the reins, Gary Flandreau from NASA's JPL. Armed with only his trusty pencil and some serious know-how, he was tasked to plot out an optimal path for space probes in order to reach Jupiter, Saturn, Uranus, and Neptune, the four gas giants of our solar system. It turns out that through careful calculations, these planets would be aligned at certain points during the late 1970s into the early 1980s, creating a celestial necklace around Earth. Setting spacecraft off on its route meant they'd get gravity boosts like being pulled along by an invisible rope, something unheard of until this moment in history. NASA was given a once-in-a-lifetime opportunity when Flandreau discovered that an alignment of planets would allow them to propel two spacecraft on a journey from Earth to Neptune in just 12 years, compared with the normal 30. With no time to lose, they swiftly reacted and launched Voyager 1 and 2 only 15 days apart during the summer of 1977. Fast forward 45-plus years later. These twin explorers are still working hard, making history every day as they send back groundbreaking information from distant corners of our solar system. For over 4 decades, Voyager 1 and 2 have established themselves as incredible cosmic pioneers. Skirting the moons of Jupiter and Saturn with astonishingly close views, they revealed a world far more dynamic than ever expected, one filled with active volcanoes and icy fields unheard of before their discoveries. Little did anyone know that these interstellar probes would reinvent our understanding of distant realms. With an incredible journey spanning 14 billion miles, the Voyager probes have made history as they blaze a trail through uncharted territory. A gravity assist from Venus tested their mechanical capabilities and provided them with unprecedented access to Mercury, something never attempted before by spacecraft. Proving that size doesn't matter, these tiny Voyagers continue to surprise us in spite of margins of error measured at 10s of minutes. Their successes remind us what can be accomplished when we strive for progress beyond our reach. Voyager's mission to Jupiter was no small feat. First, they had to brave the dangerous asteroid belt 10 times farther from Earth than Mercury. Lucky for them, Pioneer 10 and 11 successfully navigated this path in the 70s so that it could be safely traversed by Voyager. To top off all these impressive hurdles, their computers only contained 69 kilobytes of memory, about a fraction of your average smartphone's capacity, yet still managed the complexities with onboard intelligence alone. But if you thought those feats were hard enough already, data gathering? Well, that relied on 8-track tape recorders transmitting back through just a refrigerator light bulb-sized 23-watt transmitter. What an amazing journey indeed. With a 12-foot wide antenna and traveling at the speed of light, Voyagers 1 and 2 continue to astonish us all with their discoveries as they plumb the outer reaches of space. Though millions upon millions miles away from Earth, these intrepid adventurers send radio signals back home that take over 18 hours just to reach us. The challenge is made even more difficult given increased interference from sources like TVs and cell phones here on our planet. The Voyager mission has brought us brand new insights into the depths of space. Our solar system is connected to an enigmatic array of objects called the Oort cloud, which stretches halfway towards our closest star. But beyond this lies a vast sea that we are only beginning to explore, interstellar space. At its edge awaits one final boundary, where our sun's influence diminishes and intermingles with cosmic wind from other stars and nearby galaxies. It's here at the heliopause that truly uncharted territory begins. Scientists were ecstatic when the Voyager probes approached 50 astronomical units AU, leading to an increase in mission funding. Unfortunately, upon crossing this landmark, no signs of interstellar transit were detected. A surprise, as it was anticipated that galactic cosmic rays would dramatically rise once out beyond our heliosphere's massive magnetic shield. Yet despite its fail-safe protection from external threats, no such indication occurred, leaving scientists baffled by what lay ahead for humanity's most successful space exploration missions thus far. On August 25, 2012, Voyager 1 sent back an unexpected report when it crossed the heliopause. While plasma density increased as expected, there was no change in magnetic field direction. This puzzled mission specialists who had assumed a shift would take place upon entering interstellar space dominated by other stars' fields. The mystery deepened with each new data transmission from what is now our most distant spacecraft exploring vast and unknown regions of the universe. In November 2018, Voyager 2 embarked upon an incredible mission to the edge of our solar system, minus 120 astronomical units away from Earth. Surprisingly, when it arrived, its twin had 6 years prior. There were no changes in the magnetic field, which seemed strange according to theoretical models. The Sun's 11-year cycle should have caused ebbs and flows similar to that of a solar wind, but instead was at its peak strength when Voyager 2 got close, suggesting that the heliopause might reach even farther out than first thought. As these probes explore closer into interstellar mediums, we get ever nearer to unraveling this cosmic enigma. The data from our distant probes reveals some tantalizingly small changes near the heliopause, but on a much larger scale, there has been virtually no variation in its magnetic field. This perplexing phenomenon raises questions about whether or not these spacecrafts have really left solar system's boundaries and ventured into interstellar space, as evidenced by an increase of galactic cosmic rays and plasma density detected by the probes. Academics are divided over this notion. While one side argues that we're still within our own heliosphere, others seem certain they've reached uncharted waters. To truly know what lies beyond requires us to send out further exploratory missions. The Voyager spacecraft have shown remarkable durability throughout the course of their 50-year mission, powered by technology from 1970s with just 5 instruments, Voyager 2, and only 4 remaining operational onboard Voyager 1. Despite these limitations, NASA engineers were able to provide a reliable power source for both probes in form of radioisotope thermal generators, which convert heat generated from plutonium decay into electricity. An impressive feat considering that this must be done despite diminishing energy output, about 4 watts per year. 3 years ago, engineers faced a tough decision: shut down the heater or risk losing data from vital instruments for navigation and science. But despite being tested beyond its limits in extreme temperatures, that crucial cosmic ray detector stayed on, astounding everyone's expectations. Even as Voyager 2 moves further into interstellar space, critical features like the magnetometer and plasma science instruments remain operational due to their strategic placement closer to the main body of the spacecraft, which is kept warm by heat produced by computers. Truly remarkable feats for this 43-feet-long fiberglass boom-mounted machine. It's hard to imagine, but the Voyagers are still on an incredible intergalactic journey that will last for centuries. If all goes according to plan, and with a reliable source of power, these spacecraft could soon take us even further than ever before. The grand finale? In 16,700 years, Voyager 1 is expected to reach our closest neighboring star, Proxima Centauri. After reaching its destination, Voyager 2 isn't far behind, following suit 3,600 later in this epic quest through space-time which has no end in sight. Millions of years from now, long after humanity is gone, they'll be making their rounds around the galaxy itself. Human exploration and scientific curiosity is limitless. While our own blueprints may only last a short while, the Voyager spacecrafts continue their odyssey through time and space. Who knows what discoveries they will make before finally reaching their destination? We want to hear your thoughts on this incredible journey below, and don't forget to subscribe for more news.